On this quick video, we'll explain a bit more about how Shipa supports stateful applications. There's an increasing number of applications being deployed in Kubernetes today that requires access to persistent storage, and in order to attend this need, different vendors are going to market with different storage solutions that may target a specific or a broad set of use cases. We understand that the platform and DevOps engineering teams are responsible for supporting different storage vendors across different clusters and more, which are complex tasks, while providing access to volumes to their developers. Not to say that they need to understand the structure of PVs, PVCs, how each storage vendor operates and more, which makes this responsibility even more complex. It's also important to notice that storage on Kubernetes today is not very developer friendly, which makes the development team rely even more on the platform and DevOps engineering team. Seeing that scenario, Shipa developed a storage interface that allows platform and DevOps engineering teams to create seamless interfaces to storage on Kubernetes, no matter what the provider they are using. Allows volumes to be dynamically provisioned when pools are created or updated. Gives developer easy access to volumes at the pool level, where the only thing they have to do is bind or unbind volumes to their applications, which requires no knowledge of how to create PVs, PVCs, attach volumes to pod, operate these objects, and so on. In order to deliver this, Shipa breaks down the storage interface into two different objects. First one is volume plans, which are defined by the platform or DevOps engineering team. These volume plans will be pointing to the storage class of the desired storage vendor in the different Kubernetes clusters. Different volume plans can be created to point to different vendors. It is also important to mention that the volume plans are not tied to specific clusters. So if you have multiple clusters with the same storage vendor and class, the same storage plan can be used for creating and managing volumes across these multiple clusters. The second object is volumes itself, and they are the actual volumes, which, depending on the permission defined by the platform or DevOps engineering team, developers themselves can create, bind, unbind, and delete these volumes. Permissions can also be reduced, where developers can maybe only bind or unbind volumes that have been created and are already available at the pool level to their applications. Let's have a look at an example on how to do that on Shipa. For this example, we will be using the Shipa CLI primarily, and the functions that we're going to be using for this quick demo and example are basically within the Shipa volume category. So if we do Shipa volume in the CLI, we can see the different options we have: bind, create, delete, info, the volume plan management itself, and so on and so forth. Again, the platform engineering team or the DevOps engineering team they do have access to all of these options as admins, and they can restrict the access that they want to give to their developers. Either you can allow them to create plans as well, or maybe they can create volumes, or maybe they can only bind or unbind volumes. For this example, we'll also be using a cluster we have on GKE. We have a cluster called GKE1, which is already tied to Shipa. And if we see on persistent volume claims, we have no volume claims on that cluster, just the storage class that was already created by default by GKE. GKE1. If we go to Shipa, we can see that we have a GKE1 cluster. It's already in there, and we have some applications deployed to it. So let's go back to our CLI. The first thing we're going to be doing is Shipa volume plan list. If we list the plans we only have one plan that was already created before, called Storage OS, which is pointing to a storage class using Storage OS as the storage vendor that is present on another cluster. As we're going to be using this GKE, we actually need to point to standard as the storage class. So let's create a new volume plan pointing to that class. You can do that through the volume plan create. and you have to pass the name. So let's call it GKE persistent storage, maybe GKEPS, and then storage class, it's gonna be standard, which is what we have right here. Standard. Great. If we list, we're gonna see now we have GKE. That's great. For the sample, if we do Shipa volume list to list the volumes, we see no volumes have been created. When creating volumes, you have two different options. One is to create that through the pool dynamically. So when you create a pool, it creates the volume automatically and makes it available at the pool level, or you can create it through the Shipa volume create option. If we look at one template, you can see for a pool creation, you can see how this is dynamically created when a pool is either created or updated. You can pass the volume plan and the access mode, capacity, and so on and so forth. So this is executed when you run a pool update or a pool create. But in our case, since the pool is already in place, we're gonna be using the volume create option. So let's do this. We're gonna do Shipa volume create. We're gonna be calling GKE1 vol1, for example. The volume plan, which is the plan name, which is the volume plan we created, it's called GKE persistent storage, or PS. The pool is gonna be pool GKE1, which is the pool in Shipa that is tied to that cluster. Team is admin, because it's just the team I'm using right now. Capacity is gonna be 1 gig. And my access mode, it's gonna be read write once. Let me just copy this to make it faster. Okay, volume successfully created. If we do Shipa volume list, we can see the volume is available, but right now it's not bound to any application. So this is what we mean by the volume is available at the pool level. So users with access to this pool can see this volume as available and can bind it to their applications if they're part of the same pool. So when we look at our Shipa dashboard, we can see, let's get one application that is using GKE1 as a pool, app1. Okay, so app1 is using that pool, is deployed in that pool, GKE1 pool, as you can see here. If we go back here, let's see, let's shell into that app, Shipa app shell -a app1. If we do mount, if we list the content of mount, it's pretty empty right now. So let's use that. Let's bind the volume we created to this app inside the mount the MNT or the mount directory. Shipa volume list. Here's our volume. Shipa volume bind we're going to be using. And the volume bind can be done by the platform or DevOps engineering team, or can be easily done by any of your developers. They don't need to understand any Kubernetes objects, PVs, PVCs, maintain any of that or write any of that. So you give your developers more freedom to operate, and you give them more independence, which buys more time back to the platform engineering team. So let's bind it. So it's going to be the volume name, GK1, vol1. And then the mount point is going to be mount volume1. App is going to be app1. Okay. This is going to restart and bind the volume. And if we go back to GKE, we can see for cluster GKE1, now we have our volume here. Great. Volume successfully bound. Now, if we go to Shipa app shell into the app again, and we list the mount folder, we have our volume1 there. If we exit the app and we do a Shipa volume list, we can see the volume we have now, it's bound to this application. And that's it. Me both as either a platform engineering development team or a DevOps team, or either even as a developer team, I haven't designed, created, maintained, or did any single YAML file. I don't know the intricacies of Kubernetes in this case. I don't need to learn how Storage OS or Google Persistent Disk works. I don't need to understand how to bind it to my pods. I simply use a Shipa volume-bind or Shipa volume-create, and that's it. And the same way goes by Shipa volume-unbind. If you don't need that volume anymore, you can just do GKE1, vol1, and then we have it mounted on MNT, vol1, and the app is app1. Great, volume unbound. And if we list the volume is here, but no binds anymore. So at this stage, the volume is available in the pool again for other developers that have access to the pool or other applications that I want to bind it to. So if you want to even move volumes between applications for test, you can do that as well. And if you don't need the volume anymore, Shipa volume, delete, you can delete the volume by just using the volume name. In our case, GKE volume-1. Volume successfully deleted. And if we go back on GKE and we refresh, the volume is no longer there. So Shipa takes care of cleaning up all the objects and everything that is required. Again, this allows platform and engineering teams to be much faster at provisioning and making resources available to the developer. At the same time, it gives the developer a lot more freedom to use and consume resources they need without having to learn Kubernetes and spend hours developing and maintaining YAML. At the end of the day, nobody wants to become or be known for a YAML engineer, but rather you want to be known by what you develop as an application or a platform itself. Hope you enjoyed. Thank you.